Right, so this is going to be the review video for the test tomorrow. What I did though first is I put in the review worksheet we did in class, so you can take a look at this and go through it, and these problems should give you a pretty good idea of what's on the test for tomorrow. All right, so what I'm going to do in this video is go over some of the problems that are going to be on the test. I'm going to focus on trig identities, but I will just take a quick look at some of the other stuff that'll be on there as well. Okay, so some of the problems you want to know how to do are something like tangent of inverse sine of x. Right, and the problem will basically say to take that and convert it into an algebraic expression. Now, if you see inverse sine, or if you see it written like this, arc sine, those two things mean the same thing, okay? So what I would do with this problem is start with the inside function. And we know that when we use inverse trig, the answer is going to be an angle. Okay, so I'm just going to say inverse sine of x equals theta. And then I'm going to rewrite that by taking the sine of each side. And I get x equals sine theta. Right, now from here, okay, what I want to do is draw my right triangle diagram. Okay, I know that sine is opposite over hypotenuse, so I'm going to let the side opposite be x and let the hypotenuse be 1. Okay, now I can find the third side just by doing the Pythagorean Theorem. Okay, call it a for now, but we're going to be solving for that. So a squared plus x squared equals 1 squared. All right, so we get a squared equals 1 minus x squared. And then our last step to solve for a, take the square root of both sides. And we get a equals the square root of 1 minus x squared. All right, so now we know all the sides in our triangle. Okay, originally, they wanted us to find the tangent. Well, tangent is opposite divided by adjacent. X divided by the square root of 1 minus x squared. Now, what they're probably going to do on the test is they're not going to leave the root in the bottom, so we'll fix that. So we get x times the square root of 1 minus x squared in the top, and 1 minus x squared in the bottom. Okay, so there's going to be a few problems that are very similar to that on the test. All right, next type of problem is going to involve solving problems graphically. And for this type of problem, what I'm going to do is say to find all answers in a certain window. Okay, so we've talked about the kinds of problems where you have to write all answers, or sometimes we just have to find answers within a certain window. All right, so what I want to do for this one is let's find all the answers within one period. Okay, so let's set our window. So to do that, let's figure out the period here. Right, so the period for secant is 2 pi, period for cotangent is pi, and the least common multiple is 2 pi. So if I want all answers within one period, okay, I have to have a window that's 2 pi units wide. Now, there's several ways I can do that. I can go 0 to 2 pi. I could go negative pi to positive pi. There's no set way that you have to do this. On the test, I will specify what I would like. Okay, so it'll be written in the directions what to go between. In this case, I think I'm just going to go 0 to 2 pi. Okay. And let's just hit graph. All right. And remember that we're trying to calculate where this thing hits 0. All right, so it looks like we're going to get 2 answers per period. Okay, we're going to get 1 here, 1 here. All right, and since they said just find the answers within one period, we do not need to write plus 2 pi n on the end. Okay, if they said to write all answers, then we would. So let's go second, calc 0. Okay, get our first 0. And that's at 0.0 6, 7. And let's see, our second root, second calc, 0. We go to the second one. And that's at about 2.48. And that's it. Okay, if they ask us to do this in degrees or radians, that's another thing we need to pay attention to. Okay, so make sure if they ask for that, you put your calculator in the right mode. Again, the way you know what mode to be in, if it's a multiple choice question, look at the answers. Okay, if you saw answers written like this as a choice, okay, A would be correct because the answers are in radians, and that's the mode my calculator was in. Now, if they have this, those two answers are wrong, okay, because they are in degrees. All right, so just make sure you look at the multiple choice answers, look and see if they're in radians or degrees, and set your mode correctly. The last part of this review is going to focus on the trig identities. So here's a problem that is similar to something that's on the test. And the trick here would be to change everything to sines and cosines. So if I change the top to be in terms of sine, I get 1 over sine. And the bottom, we can write as sine over 1. Now, when we do this out, the way you divide two fractions is you leave the one in the top the same, take the one in the bottom and flip it. And in this case, we get 1 over sine squared. Right. Now, one thing they might do to clean that up a little bit, if we flip sine, okay, and we get cosecant, well, if you flip sine squared, you get cosecant squared. Right, so if you take cosecant and divide by sine, it's the same as the cosecant squared. All right, let's take a look at this example. All right, so in this one, what we're looking at here is a little different than the last one. Okay, the last problem didn't have something on the left and the right to start. Okay, this one does. So we know what we're supposed to end up with, and we know what we're starting with on the left. And our goal is to make the left-hand side look like the right. Okay, so it's a little bit easier because you kind of know where you're supposed to stop. All right, first thing I'm going to do on the left-hand side is distribute out cosine. Okay, so we have cosine times tangent. Whoops, let's get rid of our parenthesis. So cosine times tangent plus cosine times cotangent. All right, and now just leave that right-hand side the same. Okay, we're just going to keep working with the left-hand side until it finally turns into the right. Now, trick we use all the time, let's change everything to sines and cosines. So we get cosine over 1, tangent becomes sine over cosine, plus cosine over 1 times cosine over sine. All right, now I'm going to multiply together what I can. So on the left, I'm going to get, let's see, cosine. Actually, you know what? On the left, what we can do, before we even multiply, why don't we cancel out those cosines? Since we have one in the top, one in the bottom. So I have sine over 1 plus cosine squared over sine. All right, now everything is written in terms of sine and cosine. There's really nothing else we can do with that trick. Okay, but the next trick we could do would be to find a common denominator. Okay, one way to find a common denominator is just to take the two that you have and multiply them together. So the common denominator here is going to be 1 times sine. Now the fraction on the right already has that as the common denominator. Okay, so we're just going to leave that fraction alone. The fraction on the left does not. So what I'm going to do on the left is multiply both the top and the bottom by sine. Okay, so now in the top I get sine times sine, which is going to be sine squared And then in the bottom, I have sine times 1. That's my common denominator. Okay, now this we have to recognize as something special. Okay, that's a trig identity. Sine squared plus cosine squared is equal to 1. And now my last step, this is a reciprocal identity. If you take sine and flip it, you get cosecant. And that's exactly what they said we should get. All right, so a lot of different things in that problem. Distributive property, then we changed to sines and cosines, canceled out, found a common denominator, and then at the very end we had a Pythagorean and then a reciprocal identity. Okay, so on your reference sheet for the test, you want to make sure you have all the fundamental identities. Okay, another problem. This time we have a fraction on the left to start, so we're not going to use distributive property like we did last time. But I think right off the bat what I would do is just change everything to sines and cosines. So we're going to have sine over 1 times sine over cosine divided by secant, which is 1 over cosine. All right. Now we're going to be dividing by this fraction, so what I would do is flip it and change everything to multiplication, so we don't have a fraction over a fraction. So we're going to have sine over 1 times sine over cosine times, now flip it and write it as cosine over 1. Okay, and by doing that, one thing that's going to happen right away, cosines are gone, and now I'm just left with sine times sine in the top, 1 times 1 in the bottom. So we have sine squared theta. And if I go back and look at the original problem, they wanted as 1 minus cosine squared. Well, if we remember the trig identity sine squared plus cosine squared equals 1. If you take and put this on the other side by subtracting it, you would have sine squared equals 1 minus cosine squared. So we can change sine squared using the Pythagorean identity to 1 minus cosine squared. And that's exactly what they were looking for. Okay, so here's a problem where they don't tell us what's on the right-hand side. We are just simplifying this identity. Okay, versus the other type, when you know what's on the left and right to start, that's verifying. All right, so let's just go through and see what happens. First thing I would try is change everything to sines and cosines, okay, and see what happens. So we would have 1 over sine minus, I'm going to write that as a fraction, sine over 1, divided by cosine. Now, the only thing I can really do is find a common denominator in the top and then hope that something just works out from there. So in the top, I'm going to find a common denominator, and that's going to be the product of the two denominators I have, sine and 1. So the common denominator is sine. Okay. Fraction on the left already has it. Fraction on the right. I'm going to multiply top and bottom by sine. So we're going to get sine times sine, which is sine squared. 1 times sine, okay, that's already in the bottom from the common denominator. And all of that is divided by cosine. All right. So now there's something here we should recognize, similar to a previous problem. 1 minus sine squared is cosine squared. So now we have cosine squared divided by sine, and all of that divided by cosine over 1. So, like we've done before, instead of dividing a fraction by a fraction, let's keep the top the same and multiply by the reciprocal of what's in the bottom. So we have cosine squared over sine times 1 over cosine. Now I can cancel cosine from the bottom and a cosine from the top. So I'm left with cosine over sine. And if we remember the quotient identities, or sometimes they're called tangent and cotangent identities, cosine divided by sine is cotangent. Right? So that one simplifies very nicely to just a single trig identity. All right, so I think that's a pretty good review for the test. The test is multiple choice, mostly multiple choice, about 15 questions. Some of it you will need a graphing calculator for. Okay, so